Betelgeuse, a colossal red supergiant nestled in the Orion constellation, has long fascinated both professional cosmologists and everyday skywatchers. Its size alone commands attention. It's about 700 times the diameter of our Sun, making it one of the largest and most luminous stars visible to the naked eye from Earth. Located roughly 642 light-years away, Betelgeuse isn't just another twinkling dot in the sky. It's a towering celestial powerhouse, an essential piece in the grand puzzle of stellar life cycles. If Betelgeuse were to suddenly appear in the center of our solar system, its surface would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, and Mars in the process. Its massive size alone has made it one of the best real-world laboratories for understanding how massive stars are born, live, and ultimately die. In recent years, Betelgeuse has been acting strange. Its brightness has fluctuated in ways that caught the attention of astronomers worldwide. While stars do naturally vary in brightness due to internal processes, Betelgeuse's recent dimming episodes have been unusually dramatic. These dips have triggered widespread speculation, not just in scientific circles but also among the public. Many began to wonder, is Betelgeuse about to go supernova? A supernova, after all, is not just any event, it's the spectacular, cataclysmic death of a massive star. And for a star like Betelgeuse, its end won't go quietly. When the time finally comes, the explosion will be so powerful and so bright that it could outshine the moon and be visible even in the daytime sky for weeks, possibly even months. At the core of Betelgeuse, like in all stars, nuclear fusion has been the engine keeping it alive. Initially, it fused hydrogen atoms into helium, releasing vast amounts of energy in the process. But as time passed and its hydrogen supply dwindled, the star began fusing heavier elements like carbon and oxygen. Eventually, this process moved up the periodic table to even heavier elements like silicon, until finally it reached iron. But that's where fusion halts. Unlike lighter elements, fusing iron doesn't release energy, it absorbs it. When a star starts building up iron in its core, it's like a ticking time bomb. Gravity begins to win the eternal tug-of-war against outward pressure, leading to a sudden collapse of the core. This core collapse is what leads to a Type II supernova, an extremely powerful explosion that rips the star apart. When that moment comes for Betelgeuse, the results will be truly extraordinary. In just seconds, it will release more energy than our Sun will produce in its entire 10-billion-year lifetime. Telescopes, both on Earth and in space, have been pointed at Betelgeuse for years in preparation for this event. But the most interesting clues might not even come from what we can see with our eyes. Scientists are paying close attention to something much smaller: neutrinos. These nearly massless particles are some of the first messengers from a dying star. Long before the first flash of visible light reaches us, neutrinos will have already raced across the cosmos at nearly the speed of light. That's why global observatories like Japan's Super Kamiokande and the IceCube Neutrino Observatory in Antarctica are on high alert. These facilities are designed to detect these elusive particles and can give us an early warning that Betelgeuse is about to explode. And when the supernova does finally occur, it won't just be a light show. It will be a cosmic fireworks display across the entire electromagnetic spectrum, from visible light to gamma rays. This cascade of radiation will allow scientists to collect priceless data across multiple wavelengths, using everything from the James Webb Space Telescope to ground-based observatories. The resulting flood of information will improve our understanding of supernova mechanisms, neutron star and black hole formation, and how elements like gold and uranium are created and spread throughout the galaxy. What makes this event so important, besides the spectacle, is how close Betelgeuse is to Earth, cosmically speaking. Most supernovae that we study are in distant galaxies, too far away and often obscured by interstellar dust to study in detail. But Betelgeuse, at just 642 light-years away, is close enough to give us a front-row seat to the action. That proximity means astronomers will be able to capture details never before seen, refining our models of how stars die and what happens afterward. They'll be able to observe the shock waves, the ejection of matter, the creation of a neutron star, or possibly even a black hole, and track the evolution of the remnants over time. This will be one of the most comprehensive studies of a stellar death ever conducted. But the impact of Betelgeuse's supernova won't be limited to scientific circles. For thousands of years, humans have looked up at Orion and marveled at the bright red glow of Betelgeuse. Its disappearance will be felt deeply by anyone who has admired the night sky. The star has been a constant for generations, a glittering jewel in one of the most iconic constellations. When it finally fades from view, it will serve as a stark reminder of how dynamic and ever-changing the universe truly is. Yet, in that cosmic loss, there will also be a resurgence of interest in space. The public's attention will once again be focused upward, wondering about the secrets the universe holds and the powerful forces at play beyond our world. Fortunately, despite its dramatic end, Betelgeuse poses no real threat to life on Earth. Its distance ensures that harmful radiation like gamma rays or cosmic rays will dissipate long before reaching our planet in any dangerous form. Some minor atmospheric effects might occur, perhaps a temporary increase in auroras, those shimmering lights normally confined to the polar regions. These auroras could reach lower latitudes, offering people around the globe an unexpected and beautiful light show. But beyond that, Earth is safe. We get to enjoy the beauty of the supernova without fearing its consequences. The scientific value of observing Betelgeuse's explosion is immense. Not only will we learn more about the life cycle of massive stars, but we'll also gain insights into the origins of the elements that make up our world, and ourselves. Every atom of oxygen we breathe, the calcium in our bones, the iron in our blood, all were forged in the hearts of stars or during the violent moments of a supernova. By studying Betelgeuse, we get to witness that process in real time. It's not just about understanding a star's death, it's about understanding life itself. It will help answer deep cosmic questions about matter, energy, time, and the fundamental structure of the universe. And there's more. Betelgeuse's explosion could also help us understand two of the biggest mysteries in astrophysics: dark matter and dark energy. These are the invisible forces that influence how galaxies form, how the universe expands, and how everything holds together. During the supernova, certain signals, perhaps in the form of unusual neutrino emissions or gravitational waves, might offer clues about these enigmatic phenomena. If scientists are lucky, they may be able to detect subtle anomalies that hint at what dark matter really is or how dark energy behaves in moments of extreme cosmic stress. This is the kind of data that could redefine our understanding of physics. The gravitational waves created during Betelgeuse's core collapse will also provide a rare opportunity. First predicted by Albert Einstein and only recently observed with the help of instruments like LIGO and Virgo, these waves are distortions in the very fabric of space and time. If the explosion is powerful enough, the resulting gravitational waves could be detected and mapped. That would give scientists another dimension of data to analyze, allowing them to study the internal collapse of the star in incredible detail. It's the difference between watching a concert and actually hearing it live. It's an entirely new sensory experience for astronomy. In short, Betelgeuse is not just another star nearing the end of its life. It's a cosmic event waiting to happen, a multi-sensory explosion that will impact science, culture, and the way we see our place in the universe. Every telescope, every detector, and every eye pointed toward Orion will be waiting for that final, spectacular moment. And when it comes, it will be more than just the end of a star. It will be the beginning of new scientific revolutions. The light that will one day flash across our sky won't just mark a stellar death. It will ignite a deeper curiosity about the cosmos. A curiosity that has always driven humanity to look up and wonder what lies beyond. Betelgeuse's final act is a culmination of decades of research, observation, and patience. For generations, astronomers have been tracking its every pulse, every dip in brightness, and every clue it offers. This isn't just about science. It's about connection. It's about understanding how the elements that once lived inside a dying star now live inside us. It's about realizing that the death of a star could ultimately spark the birth of new ones, continuing the never